Welcome back, Highlanders, to the third and final lecture for Chapter 6. Remember, we left off last time talking about this idea of combining government control with a decentralized attitude by limiting the amount of total pollution that an industry can create, but then allowing firms to decide for themselves how much they want to pollute by allowing them to trade those pollution permits. So we're going to extend this idea of tradable pollution permits to two firms. Remember, we kind of talked about tradable pollution permits back in Chapter 1, or at least the idea of it. Now we're going to go through in a little bit more theoretical and mathematical way. Make sure you truly understand how this works. So with that in mind, I want you to imagine, again, two big power plants. We'll call them, once again, All American Power, or Firm A, and Big Energy Incorporated, or Firm B. And let's say that if left up to their own devices, each of these plants emits 300 tons of sulfur dioxide per year. Right, so 300 tons of pollution is being emitted. Right, now the government's going to set an emission limit to 300 tons total across the entire industry. So there's two firms in the industry, right? They each prefer to pollute 300 tons individually, which is 600 tons total. But the government says that's too much. We're going to set it to the optimal level of emissions that maybe we found in the last chapter. Right, so we're going to set it equal to 300 tons total because there's two firms. You each get 150 permits. Right, so each firm can pollute 150 tons into the atmosphere and still stay at that 300-ton limit. Right. Now, I want you to go ahead and assume that both firms are going to have a unique marginal abatement cost curve, or marginal abatement costs. So with that in mind, what is that going to look like on this particular graph that we're about to go over? So let's go ahead and check out that graph of extending tradable pollution permits across two firms. So we're just going to draw a graph as we've been normally drawing one, the vertical axis and a horizontal axis. So your graph's going to look something like that. Again, we'll be measuring damages up here on the vertical axis, and we're going to be measuring emissions down here on the horizontal axis. Right? And we're going to go ahead and do something a little bit different, something we haven't done before. Is we're going to be measuring these firms on the exact same graph. So we're going to be looking at firm A here from left to right, and then we'll be looking at firm B over here from right to left. So let's go ahead and draw these marginal abatement cost curves. Right, so firm A might have a marginal abatement cost curve that looks like this. So we'll call this MAC sub A, and when it hits that x-axis, that is that 300, or that maximum amount of emissions that they would prefer to emit if not regulated. Right, so again over here they have 0 emissions, and then we just have a steady increase of emissions all the way up to that maximum of 300. So that's firm A's emissions. Now firm B, their marginal abatement cost curve is again going to be going this way on this graph. So we're going to have an intersection right here. And again, they're going to have 0 emissions starting over here, and then they're going to be increasing from right to left. All right, so the way to read or interpret this graph is that over here, firm A is emitting 300 emissions, right? As they abate emissions, and they're going to keep on having less and less emissions all the way till they get to 0. Over here, firm B is emitting 300, having a total of 300 emissions. And as they continue to abate emissions, they're going to be moving to the right there along that marginal abatement cost curve, right? So they're going to be getting rid of emissions as they go further to the right. So that's the way to kind of think of how this graph works, right? Now let's go ahead and say that again, each firm here is starting out operating where they have 150 emissions each, because that's the rule that the government set. So in other words, this is where firm A is currently operating here using their marginal abatement cost curve for A. There we go, getting back to full screen mode. And this is where firm B is currently operating using the marginal abatement cost curve for firm B, right? So at firm A, the point at which firm A is operating initially, right, they are abating 150 tons of emissions because they're going from 300 down to 150, and then they have permits for the other 150 tons. And we're going to go say that their last unit of abatement is $500. So right here, is the $500 that firm A is spending on their last unit of abatement. Firm B, on the other hand, is operating at point B initially, where they will abate 150 tons and have permits for 150 tons of pollution, and their last unit is going to be costing about $1,500. Again, so far this is the information that I'm kind of giving you here. Again, we'll go through how to calculate all this in the next slide, right? But again, here at point B, they are abating 150 tons, but have permits for 150 tons of pollution. Again, their last unit of abatement cost is $1,500. And then we're going to say that where these two curves intersect here, it's going to be right in between. We will call that 1,000. All right, so let's look at this graph and see if we can kind of figure out in general what's going on. So we know that firm A here as would be willing to sell a pollution permit for anything over $500, because $500 is what it costs them to abate emissions at their current point at which they are operating. Firm B, on the other hand, would be willing to pay up to $1,500 for a permit, right? Because again, anything cheaper than $1,500 is going to be less costly than abating emissions at their current point of operation, right? In other words, firm A is willing to sell permits for any price over 500. Firm B, on the other hand, is willing to pay up to $1,500 for a permit when they are both operating at the level of permits that is given to them by the government. So as you can see here, there's going to be an opportunity for both firms to gain with some exchange here, right? And so with that in mind, there's a trading range that exists between $500 and $1,500 here. So in other words, this is what we call the trading range for these two firms. They're both going to be able to benefit from exchange as long as the price is between those two amounts, right? Again, any price over 500, firm A is going to benefit. Any price under 1,500, firm B is going to benefit, right? Now, as they continue to start trading these pollution permits, this trading range is going to get smaller until it gets to an equilibrium. So the more they start buying and selling permits, this range is going to get smaller and smaller, right, until an equilibrium. Sorry, I didn't mean to do that. So it gets smaller until we reach an equilibrium here, right? And at that equilibrium, right, the last permit will get sold or traded for 1,000. Clean that up for you. There we go. All right, so how much will each firm have at this trading range? Well, again, that's another thing that we are going, or how much will each firm have at this equilibrium after engaging in this trade throughout the trading range? That's something that we're going to be figuring out in the next slide, how to do mathematically. But for now, we'll say that firm A will have about 110, emissions at this level, and then firm B will be right here at 190. So this 110, this is going to be our E star for firm A, and this 190 is going to be our E star for firm B, right? So how do we get there? Well, because firm A is going to sell 40 permits to firm B. And again, right now I'm just kind of giving you these numbers so you can see how the story works, and then we'll go through how to calculate these numbers later. So again, the story goes initially, each firm A and B is going to try to pollute 300 tons of pollution. Having said that, the government sets a rule that says that we want 300 tons total across the both of you, so we're going to give you each 150 permits. So that's why each firm starts at their respective points. Firm A starting at point A, firm B starting at point B. Right now, as you can see, it's going to cost a lot more to get rid of emissions for firm B than firm A when they're at these starting points where each has 150 permits. So firm A says, hey, it costs you a lot more to get rid of this pollution than it costs me. How about I start selling you some of these permits? And again, firm B will agree. So firm A is going to be selling permits again for any price over 500. Firm B is going to be buying permits for any price that is less than 1,500. Right? So firm A will sell 40 permits to firm B, with the last permit going for a price of $1,000. Firm A there will then have 110 total emissions, right? Having sold 40 of their permits to firm B. Firm B is going to have a total of 190 emissions after having bought 40 permits from firm A. Right now, notice that 110 plus 190 is still equal to 300. Right, so they're going to still be operating under or at that 300 300 ton pollution capacity that the government has set. So they're not doing any more damage to the environment when they were permitting or when they were polluting 150 each. Right, they're just now doing it in a much more efficient way. In order to describe that efficiency, let's go ahead and go through a calculation of how to do this. Right, so let's say the government sets the pollution cap at 100 total emissions and gives 50 permits to each firm. Right, and these are their respective marginal abatement cost curves. So let's go ahead and go through this problem together. So I'm going to exit my full screen mode so that we can get to the different colors a little bit more easily, because this is going to be one of those big graphs where a lot of colors are going to be needed. All right, so let's go ahead and start thinking about what our constraints are. First is we do have a permit constraint. Remember that we want 100 total permits possible. Right, so with that in mind, right, again, E sub A plus E sub B does need to equal 100. Or again, we could say that E sub A is equal to 100 minus E sub B, just by rearranging that equation there. All right, so let's go ahead and start drawing out this graph, and then we'll start graphing these curves and see what we can find out here. So again, we're going to be measuring dollars up here, and we'll be measuring emissions over here. Right, and once again, we're going to have a marginal abatement cost curve that's going to be sloping this way for firm A as they move from left to right. All right, so again, we're talking about the number of emissions for firm A. We're going to be counting them up from left to right, which means we're going to be abating them from right to left. Right. Now, again, if you want to figure out where that curve starts, it's the same process that we've been doing. You just got to set E sub A equal to 0. And when you do that, MAC sub A is equal to 300. Right. If you were to set MAC sub A equal to 0, right, then we know that the max number of emissions for this firm would be equal to 100 by itself. Right, so again, we got 300 up here, and we got 100 down here. Right, so in other words, this firm would be emitting 100 emissions if completely uncontrolled or unregulated. Right, if you wanted to abate all emissions all the way down to 0, then the abatement cost of that last emission would be $300. Right, so again, this firm is measuring emissions from left to right there, or from 0 to 100. Right, now we need to go ahead and graph out that MAC sub B curve. Right, that's going to look something like this. Now again, for firm A, we're going to be reading them from left to right, but for firm B, we're going to be reading emissions from right to left, which means that we're going to be abating them from left to right. So again, the zero emissions over here, and this would be their max of 100 emissions there. So as I'm sure you can already tell, there's an equilibrium that is formed and that we need to calculate, and we do that by solving our efficiency constraint. Remember, our efficiency constraint is to have these marginal costs equal to one another. So setting MAC sub A equal to MAC sub B. Right, so we're going to set these two equations equal to each other. So we're going to have 300 minus 3 E sub A is going to be equal to 200 minus 2 E sub B. All right, now we've got one equation with two unknowns, and that's a problem unless we can substitute this E sub A into here, because in doing that, we're now going to take our equation down to one equation with one unknown, and that's something we can solve. So plugging that in, we got 300 minus 3 times 100 minus E sub B, and that's going to be equal to 200 minus 2 E sub B, right? So let's go ahead and math that out. We got 300 minus 3 times 100, which is another 300. Now we've got negative 3 times a negative E sub B, so that's going to be positive 3 E sub B. Again, don't forget to distribute that negative sign through. And that's going to be equal to 200 minus 2 E sub B. Right, so these 300s cancel out, so what you're left with is 5 E sub B is going to be equal to 200. And that means that E sub B star is going to be equal to 40, and therefore we know that E sub A star is equal to 100 minus that E sub B, or 40. That's going to be equal to 60. Right, so we know here that this equilibrium, firm A is going to have 60 emissions. Firm B here is going to have 40 emissions. Right, so that's the first thing that we can figure out. Now we can plug that E sub A star into our MAC equation, or MAC sub A equation, in order to get what that final permit price would be. Right, so all we're doing here is we're looking at MAC sub A at E sub A star being equal to 60. So if we plug that in, right, then we should get 300 minus 3 times 60, or 300 minus 180 is equal to 120. And then we can do the same thing here for MAC sub B at E star sub B being equal to 40. So this is going to be 200 minus 2 times 40, or 200 minus 80, which is also equal to 120. So we know that this equilibrium here, so it's an equilibrium price for the, and that's our final permit trading price, which is going to be 120. So that's where these firms are going to want to end up. That's not where they start. Remember, where they start is that each firm is given 50 permits, right? So if we're measuring permits from left to right we're measuring emissions from left to right for firm A, and they're getting 50 permits, that means they're going to have 50 emissions, right? So with that in mind, their starting point is going to be right here somewhere. And that's for firm A. Right. We also know that firm B is going to start with 50 emissions. So if we're going to be starting from, or if we're going to be measuring emissions for firm B from right to left, then we know that 50 emissions is going to occur over here to the left of 40, right? And so that's where firm B is going to start. All right. So with that in mind, we can go ahead and figure out exactly what those marginal abatement costs are for those starting points for each firm, right? So what we're going to do here is now we're going to look at MAC sub A at the government level of emissions, which is 50. So MAC sub A at E sub A equals 50 is 300 minus 3 times 50, and that's equal to 300 minus 150, which is 150. And then we're going to look at the same thing for firm B. So we're going to look at MAC sub B at E sub B is equal to 50. And so that's going to be 200 minus 2 times 50, which in this case is 200 minus 100, which is equal to 100. So initially speaking, firm A is going to start off with 50 permits. That means they're going to be emitting a total of 50 emissions there. And the cost of abating their last emission for firm A is 150. The cost of abating the last emission for firm B, however, is just 100, right? So in other words, it's cheaper for firm B to abate emissions when they're starting out that level of 50 than it is for firm A. Right, so as you can see, there's going to be some opportunities for trade here in the near future. But let's start off by taking a look at these firms' initial allocation. It's kind of where these firms start. All right, so let's go ahead and start off with firm A here, and we'll do them in red. Right, so let's go ahead and calculate the abatement cost for firm A. So that's the first thing that we're going to be looking at here. In our total abatement costs just for firm A, right? So remember that abatement cost is the total abatement cost is the area under the marginal abatement cost curve at the number of emissions. And we're talking about the initial allocation of 50 permits each. For firm A, which started off polluting at 100 and then had to abate down to 50, right? It's going to look like the area of this triangle here. So those are the total abatement costs for firm A. So remember how to calculate the area of a triangle. It's 1/2 base times height. So that'd be 1/2 100 minus 50 times the height of that triangle, which is 150. All right, so if we calculate that out, that should be 3,750. So that's the total abatement cost for firm A when they're given 50 permits by the government, and then they have to get rid of 50 permits as a result of this rule. Now, let's take a look at firm B. So we're going to look at the total abatement cost for them. So when looking at the total abatement costs for firm B, right, then again, we got to think of firm B starting out over here with 100 emissions, and then they have to get rid of 50 emissions as a result of this new rule, right? So firm B is going to be getting rid of emissions all the way down to 50 here. So again, when you're talking about getting rid of emissions, they're going from left to right, from 100 down to 50, right? So it's the area of that triangle there. So it's going to be 1/2, again, 100 minus 50 times 100. Right, so that's going to be equal to 2,500. All right, so that's where these firms are going to start. But again, firm B now is thinking, hey, I'll be willing to sell emissions for anything over 100. Firm A is like, hey, I'd be willing to buy emissions for anything less than 150. Right, so we can see a trading range open up here between the difference between 100 and 150. Right, so again, this is our trading range. Now, where the price of these first permits are going to be, they're going to depend on their relative negotiating ability, but we do know it's going to be between 100 and 150. We also know that $120 is going to be the price of that last permit. So let's go ahead and assume for now that they're going to sell all their permits for 120, right? So again, let's go ahead and assume that the price of every permit is that equilibrium price of 120, right? So let's take a look at what happens to firm A after trade. And this is firm A after its permit trade. All right. So after firm A goes out there and starts buying permits, right, you can see that they don't have to abate nearly as many emissions as they did before, right? Instead of going from 100 down to 50, they have to go from 100 down to 60 because they're going to go out there and buy 10 permits from firm B, right? So in other words, after permit trade, firm B's abatement costs are going to go down. To this area there, right? So that's going to be the abatement cost for firm A. So this is their final abatement cost. But that's not going to be their only cost here, right? They also have to add to that the price that they pay for these permits, or the amount that they pay for all these permits, and that's going to be the permit cost. All right, so their final abatement cost is going to be the area of that triangle, which is 1/2. Oop, didn't mean to do that, sorry. The base of that triangle, which is now 100 minus 60, computer's being sensitive today, times the height of that triangle, which is now 120. So that's going to be their abatement cost. So 100 minus 60 times 120 times 1/2, right? And now we got to figure out their permit cost. So they're going from emitting 50 units to emitting 60 units of pollution. So we know they bought 10 permits. And again, I said go ahead and assume that they buy those permits at a price of $120 per permit. Right, so it's going to be 10 permits times a price of 120 each. Right, so if you go through and you calculate out that math, that should be equal to 3,600, which if you compare it to the 3,750 that they were spending before, notice that they're spending a little bit less, or it's cheaper if they buy those 10 permits from firm B than if they don't buy those permits and just abate those emissions, right? So again, they've saved some money there by engaging in this permit trade. Now let's take a look at what happens to firm B after that permit trade. So again, this is firm B after this permit trade. All right. So, in looking at this, right, again, firm B ended up selling permits to firm A. So, whereas they were abating 50 emissions before, right, now they're going to have to abate a few more given that they are selling some of their permits away. Right, so if we're looking at the total cost for firm B, right, again, it's going to be the final abatement cost, which is going to be higher initially than it was for firm B, right? But remember, now they're going to have to subtract from that their permit revenue because they're now selling permits for money, and that income they receive from selling permits can be subtracted from their costs, right? So they started off with 100 emissions here, firm B did, and then they're going to have to abate a total of 60 emissions because even though they were given 50 permits, so normally they'd only abate 50 emissions, they are going to sell 10 of those permits away, which means they now have to abate a few more emissions, which isn't that bad for them given that it's a little bit cheaper for them to abate emissions. But in any case, so this is what their final abatement cost is going to look like, right? So again, we can calculate that out as the area of that triangle. So that's 1/2 of 100 minus 40, or 60, times the 120. And then we subtract from that, there we go, we subtract from that the price they're getting per permit times the total number of permits, right? So if you do that math, that's going to be 3,600 minus 120. Again, that should be a minus sign here. And that's going to equal a total of 2,400, which if you compare that to the original cost of 2,500 is cheaper, right? So the idea, again, looking at it all here, is that this firm is now going to be doing things about $100 cheaper because they've sold those permits to firm A, right? So that is what this, sorry, I went a little too quick there. So that's what this total slide looks like here. Again, on the exam, you're going to have to calculate what is the optimal number of permits for each firm under this system, and then how firms get there, right? So in this case, it is firm A that is buying these 10 permits from firm B, who is selling those 10 permits to them. You also might have to figure out the total cost before with regards to their initial allocation, and then the total cost after this permit trade if I give you a given price for permits, which will almost always be the final price for a permit or the equilibrium price in that trading range, right? So with that in mind, be able to do a question like this on the exam, right? Again, I could ask you any of those questions, right? I could ask you who's buying permits, who's selling permits, how many permits are being bought and sold, what is the trading range for those permits being bought and sold, what is the price of that final permit, and I could ask you for the cost both before and after this permit trade for each firm. All right, so again, if you do all the math that we did here, then you should be able to answer those questions. And again, we're not really doing anything different than we've already done, right? Again, we've able to figure out what our permit or whatever permit constraint is, right? That's E sub A plus E sub B is equal to 100. That's given to you in the question. And then the efficiency constraint is just to set those two marginal abatement cost curves equal to one another. Plug in your permit constraint, and that's how you solve the equilibrium, right? Number of permits for each firm, right? Plug that number of permits into the original marginal abatement cost curves for each firm, and you're going to get the same number as long as you do it correctly, and that's going to be the final trading price for the permit. In order to figure out the trading range, you just plug in the initial allocation into each marginal abatement cost curve, right, in order to get that trading range there, right? And then from there, you should be able to see who's going to be willing to buy permits and who should be willing to sell them, right? Again, for the initial allocation, you just have to figure out the total abatement cost, right? That rule hasn't changed back from Chapter 5. It is just the total abatement cost, just the area under the marginal abatement cost curve at that initial number of permits. Right, so just be able to do that for each firm. And then as far as after the permit trade, this is the only part that's a little bit new or a little bit tricky, right? For the firm that is buying permits, you look at their final abatement costs and you add to that their permit cost. For the firm that is selling permits, you take a look at their final abatement costs and you subtract from that their permit revenue, right? And in doing that, that is going to give you the total cost for that firm, right? Again, that permit revenue is subtracting from those total costs. And again, you should see that the total cost for each firm is lower. That's why they would engage in that trade or why they'd engage in buying and selling permits. Right? So if you can do that, you should be okay or good to go for the exam. All right. So the last thing we're going to do is talk a little bit about what might be a fair or efficient way to allocate pollution permits across firms. And this isn't really something that there is a definite answer to, as there's both costs and benefits to each way of doing this. Right, so one thing that you can do is you can give permits to firms with the higher abatement costs. That would be the most efficient way to do it in terms of reducing costs, but there's a cost to doing this. You're essentially giving permits to the firms that are doing the worst job at controlling pollution on their own. In other words, you're kind of incentivizing firms to operate in such a way that they are polluting the environment more. Because the cleaner, more environmentally friendly firms that have figured out cheaper ways to abate emissions, right, those are the firms who won't be getting the permits at all, right? So again, giving permits to firms with a higher abatement costs will reduce costs more, right? But it will at the same time kind of be a little unfair in that you are rewarding the least cleanly or the most polluting firms. You could give permits to the newest firms in the industry, right? So one thing that you could do is the newer firms get the permits, whereas older firms would have to buy them from the newer firms. Right now, one problem with that is that the newest firms in the industry are usually the most environmentally friendly because they're adopting the newest technologies as they're getting their business or their building set up, right? They're probably going to start out with things like energy efficient windows or solar panels or just cleaner ways of operating, right? So you're now giving permits to the firms who need them the least, right? So again, that might not be the most efficient way to allocate these pollution permits across firms. Right, you could allocate permits through auctions, right? So whichever firm is willing to pay the most for the permits, those are the firms that get them, right? This will ensure that the permits do go to the firms that need them the most. However, this also gives the opportunity for bigger businesses to kind of roll over those small businesses, right? Essentially because they're going to have more money to buy these permits at auctions, right? So again, this could be a efficient way to make sure that permits go to the firms who need them the most, although it might be a little unequal in that bigger firms or more established firms are going to have more money to kind of smother the smaller firms during these auctions. So again, there's no perfect way to do it, but those are some of the ways that you can allocate pollution permits outside of just allocating them equally. Usually for the examples in class, I'm just going to have you go through examples where they're allocated equally, right? But in the real world, again, they can be allocated in a variety of number of ways, and none of these ways are without their potential drawbacks. All right, so with that in mind, that is the end here of Chapter 6, right? Make sure you understand the advantages and disadvantages of decentralized policy versus those policies that involve more government control, right? Make sure you know the sources of market failure. Remember we talked about in class a lack of competition, right? A lack of information, externalities, and public goods. And again, there are potential government solutions to all of these sources of market failure. For a lack of competition, there are rules that prevent these firms from colluding, right? At the same time, though, sometimes the government, if they have too many regulations in place, right, will prevent this competition from occurring. So you want a just right amount of government involvement there, not too much, not too little. For lack of information, there's regulations where the government can help provide the information that consumers need to make an informed choice. Of course, if the government has a monopoly power in that activity, then it might not be done in the most efficient way possible. Again, you could have consumers, say, dying while waiting for the FDA to approve drugs that could have been approved a lot more quickly if you allowed agencies to compete over that approval process. Right. For regards to externalities, again, the solution is to tax the negative ones and subsidize the positive ones. Again, it's kind of hard to know exactly how much those taxes and subsidies should be, and can create some unfair behavior, giving certain subsidies to, say, some groups and not others. Right. And then in case of public goods, again, the government's role will be to tax and provide those public goods if it can. Right. But remember, we talked about for every government solution, there's also a source of government failure, and we'll talk about that here in a minute. But moving on to number 3 here, be able to calculate the optimal rate of emissions for 2 firms, as well as the appropriate affluent tax rate. So give you 2 firms and tell you the government is going to institute an affluent tax rate in order to keep emissions at a certain level. Be able to calculate what the optimal rate of emissions for those firms are, as well as what the affluent tax rate is, right? And as well as the cost for both of those firms. So understand the sources of government failure, right? Remember that whenever you have government solutions, you do have government failure, right? We talked about some of those sources of government failure as being a lack of profit motive. So governments don't tend to operate as efficiently as private individuals do within the marketplace because they don't get to keep the profits at the end of the day, right? In addition to that lack of profit motive, remember that governments also tend to end up suffering from the short-sightedness effect, which is the incentive or desire to provide things that offer immediate benefits, even if the costs outweigh the benefits, so those costs are hard to identify or happen way out into the future. And then finally, there's that idea of rent-seeking and the special interest effect, which is the way of saying that sometimes government action encourages lobbying, and that lobbying gives unfair protections or favors to certain groups, and every hour, ounce of effort, or dollar you spend lobbying the government is an hour, ounce of effort, or dollar that you're not spending making your products faster, better, cheaper, or more environmentally friendly on their own. And then finally, know to find the optimal rate of emissions for 1 or 2 firms in the presence of tradable pollution permits, which are those last couple examples that we just talked about. So if you understand that, then you should be good to go for Chapter 6. And Chapter 6 is the last real mathematically intense chapter. And the next chapter, we're going to start out with some stuff that's a little graphically intense, right? But then after that, it's just nothing but kind of ideas and theories and smooth sailing from there, right? But again, if you had any trouble with these kinds of problems, please let me know. I'll be happy to help you. Just let me know if you have any questions. You can shoot me an email or come visit me in those Zoom office hours. I look forward to seeing you all again for Chapter 7. But until then, just let me know if you need anything, and take care.